Okay, students, today we're going to do our little experiment here, and we're going to try and determine what the freezing melting temperature is for paradichlorobenzene, which is the chemical in moth ice crystals. These are used to keep moths and carpet beetles from chewing on your stored clothing or carpets and laying eggs and larvae on them and all that kind of good stuff. So what I'm going to do is I have 6 grams of this measured out. Wait, now it's 5.9. Hang on. I'm gonna put one more crystal in there just to get it to 6, because I'm OCD like that, and it's gotta be 6. That enough? Nope. Another one. Let's get another one in there. Gotta be 6. If this goes to 6-1, I'm gonna be really upset. Ugh. All right. You're kidding me. It's still 6-1. It's up with, it's probably the scale. All right, 6. Stay at 6. Good boy. Okay, so we have 6 grams of paradichlorobenzene, and I have some water on a hot plate here, and right now we are trying to heat this up to about 90 degrees Celsius. I'm pretty certain that, and that's going to be right there at that 90 mark, and it's getting up there. So once it hits 90, we will put a test tube in that has the paradichlorobenzene in it, and that should melt. And then once it melts, we will remove it and we will set it back in the test tube rack, and we will chart the temperature every 30 seconds as it cools off and try and note when it changes from a liquid back into a solid. And so we will come back to this in a few minutes. Hopefully this will hit 90 degrees soon, and then we can begin. Okay, we're almost to 90 degrees Celsius right now. You can see on the thermometer there. 100 is the boiling point of water, so we're going to be below that. 90 Celsius is probably like 162 Fahrenheit. So that's like probably an average temperature for a cup of coffee if you were getting coffee at a restaurant or something like that. There's a legal limit to how hot they're supposed to serve it. So we're almost there. So we're going to put the chemical there. You can see I have it in the test tube already. That's 6 ounces. We're going to put that in the test tube. We're going to actually raise the thermometer out because we're at 90. Just lift that up there. And we're just going to leave that out for a minute. And we're going to let this, lower the camera a little bit so we can see better. And so we're just gonna let that, you can already see it's melting in there as I swirl it around a little bit. The crystals are melting. So this is well above the melting point for this chemical. And we can probably actually take this off of the hot plate. We're gonna turn the hot plate off. Actually, we'll just leave it like that. You can see it's melting. And we're just gonna melt it all down. You can see it all turn into a liquid now. Interestingly enough, when you look at the crystals, they're all at the very bottom of the test tube. That seems to indicate that the crystals in the solid form are, and that's kind of redundant to say crystals in solid form, but the crystals are denser than the liquid version. And that's why they're still at the bottom. They're not floating to the top. And that's just about gone. Yep. All right, now it's all liquid. So what we're gonna do is we're gonna remove this, and we're gonna set this on this ring stand over here. And what we're gonna have to do is we're gonna have to record the temperature every 30 seconds. Now, I made a sheet, so I'm gonna do the recording here. I hope it doesn't take that long, but we'll see. And I think the best way to do this is to take this out, put it back in the test tube rack, set the test tube rack on here, and then lower the thermometer directly in so we can then get the temperature of this air. It goes rising right up real quick. You can see the red line moving up. It's up past 50. And I'm going to start my stopwatch on my trusty dusty Apple Watch. If I can just get this thing, there we go. And the initial temperature, we're at about 70, it's still going up. We're at about 74 degrees, and I think we're stopped there. So I'm gonna take that temperature and start my stopwatch. So first temperature reading, 74 degrees. That's the start. And then I'm just gonna take and what we're gonna do is we're gonna watch for when this starts to turn to a solid. So I'm gonna try and bring this down here a little closer. So hopefully you guys can see what's going on there. I'll move this a little bit closer to the edge of the table so you can see on the camera. And it's down to 68 degrees at 30 seconds. I had a window open just to blow some air through here. So that's the first reading. And our next reading is 64 degrees. So we dropped 10 degrees in the first minute. And we're still dropping down, still dropping down, still dropping down. Next temperature reading is 61. All right, I haven't noticed any change yet in the liquid. None of it's solidified yet. Still dropping down, still cooling off. And we are down to 58 degrees at 2 minutes. And I still don't really see any change in the liquid itself. This is so exciting. This has all the excitement of watching paint dry combined with watching golf on TV. And I like playing golf, but I don't like really watching it on TV. I do find it a little bit boring. All right, 2.5 minutes. We are at 55 degrees. Do we have to 55? We have a bingo. For those of you that play bingo. And coming up on 3 minutes. In 6 seconds, let's see here. We are down to, we're at about 53, and that's 3 minutes. That's 53. 53 degrees. 53. All right, halfway to the next reading. Let's see, it's down to 52. Can it get down to my age? It'd be cool if it actually stopped on my age in one of these readings. And we are at 52. It's slowing down. Kind of like me, it's slowing down. All right. Still going down though. Still dropping. This is going to be fun transferring this video onto my computer and turn it into a YouTube video. All right, 8 seconds left to the next reading. But it is just barely coming down to 51. And do we notice any, oh, I noticed now, I don't know if you could see too well on the phone here, but I'm trying to focus in on my with my finger here to make sure I've got a good focus on this. The sides, I see some crystallization on the sides of the beaker. I hope you guys can see that, because that was kind of the point of this thing. I'm gonna try and just focus on that. And the next reading is 51. Again, now we're holding at 51. And so some of it is solid, and some of it is still liquid. All right. 8 seconds to the next reading. What's gonna happen? What's the temperature gonna be? 2, 1. It is still 51. 51 degrees. And you can see more lines in there. It is starting to change to a solid. 15 seconds into this reading. And (24), 2, 1, and 51 degrees. I think it's safe to say that's the freezing / melting point of paradichlorobenzene, because the temperature is not really changing while it's solidifying. So yeah, there's a little bit, these lines here, it's gonna start getting more cloudy. And we got 5 seconds to the next reading. And gee, any guesses on what it's gonna be? 51. That's crazy, look at that. Let me bring this up real quick so you guys can see what I'm looking at. That's right at 51 degrees. And let's get this to refocus here. Focus on me. You can see more of it's changing. All right, next reading, 51. What if I zoom in? Let me figure out the way. There you go. It's crystallizing in there. 5, 4, 3, 2, 1, and it's 50. Oh, it's like just a little below 51. Maybe it's like, it's still above the 50 though. I'm gonna call that 50. And there's more of it turning into a solid there. 9, 8, 7, 6, 5, 4, 3, 2, 1, and it's 50. Yup. And it's really, let me see if I can shake it a little bit. There's still some liquid in there. So it's interesting that at this temperature, it's existing both as a liquid and a solid. And as more energy comes out, because 50 degrees is still pretty warm, that's almost 120 something degrees Fahrenheit. So it's still cooling off. It's losing energy, and it's slowly changing it from a liquid back to a solid. All right, so we are at, now I'm reading 51 again. Huh. So we've gone back up to 51 now for 2 readings. That's funny. I wonder if my disturbing it to check to see if any of it was still liquid caused that. I guess we'll never know. We'll never know. All right, 12 seconds. 10, 9, 8. It's like New Year's Eve. 7, 6, 5, 4, 3, 2, 1. 51. 51 degrees. I hope this doesn't take 23 minutes. That will bother me. That will really bother me. while we're doing this, let me just say that I will put this data on in the Schoology folder for your class, and I'm gonna have you guys make a graph. All right, that's back down to 50 for the next measurement. And you guys can make a graph either by hand on graph paper, but you're gonna have to use a ruler and make it neat, or you can use Google Sheets. I'll try and do some directions for how to do that and put that on the Schoology too. And we'll make a graph of it, and we're gonna notice that somewhere at around 4 minutes, it started turning solid. And then we'll see when it's completely solid. And that's 50. Hovering right around that 50, 51 mark. Still not changing, just to make sure everybody believes me. Dun, 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 dun. There it is. Maybe it's coming just a little under 50 now. And let's just disturb it one more time to see. There's still a little bit liquid in there. Still a little bit. And that's, whoops, I turned the thermometer. That's 50. Yeah, but you can see just a little bit left in there that's still liquid. That's gonna be one big crystal. I'll have to heat that back up again to get it out. And that's another minute. And it's 50. The other thing you have to consider too is how accurate is this thermometer. You know, sometimes we get stuff from the lowest bidder. So, but you can still see there's still some liquid in there. And that's 50. 50, 50, 50. So you know what? I'm gonna keep taking the temperatures, and I'll video back in when it's all solid, and then I'll show you guys the data.
3 hours later.
All right, we're coming up on our 17-minute reading, which means we have like 34 data points, so I would recommend doing this on sheets. And we're now down to 44 degrees, and this thing is solid. Look at that, I can lift the whole thing up. It's one solid crystal. I'm gonna see how long it takes to get down to 40, which it's moving right along. And yeah, it's going down. You guys wanna see? It is heading down to 42 and 40, yep, 42 degrees. And the next reading will probably be 40 or below. Let me see if I can just raise this up a little higher so you can see better. Yeah, it's hitting down to 40 now, and it's below 40. It's moving pretty steadily now. That's a 39. So that's it, I think we got it. 39 degrees at 18 minutes. So 18 minutes was longer than I was hoping for, but at least we got there. Bonus track, bonus track, bonus track. Okay, so while I have the moth ice crystals here, the paradichlorobenzene, and I have the distilled water I was using, plus I still have that methyl alcohol from the quarter thing where I made the quarters turn copper. You can dissolve the moth ice crystals in alcohol, but they will not dissolve in water. They're soluble in this, they're not soluble in that. So I have about 60 milliliters of each in these two beakers, and I set the scale to 0 because I want to get the mass of everything. So that's 244.6, 244.7. I'm gonna pour the water into the alcohol, and the water should force the ice crystals back into a solid because the ice crystals are not soluble in water when I mix the water in there. So you're gonna see the crystals reform and probably sink to the bottom, but the mass should not change. Don't you change The mass should not change because there is no change in mass. There's only a change in state here. So here we go. Ready? 244.6.7. Boom. Look at that. It's different, but the mass didn't change, even though there's something new in there. Look at that. That actually looks kind of cool. Anyhow, hope you enjoyed. Brandy out.